And my deepest apologies for the mishap yesterday, both with the live meeting recording details, but unfortunately I had some technical difficulties and couldn't get online. Alright, welcome to the linked .NET user group's 1st June 2011 presentation. Today we're having Theo Jungeblut joining us all the way from Germany. He's going to be presenting LEGO for software engineers and give us some tips on how to build reusable and maintainable applications in C#. Before we head into and I hand over to Theo, just want to thank our sponsors for their continued support of the LIDNUG community, and our primary sponsors is Orgsweb, one of the hosting solutions and hosting providers out there, at Telerik, component vendor, and PostShop. Some housekeeping for June. We have 3 more events coming up after Theo. We have the Open Data for Open Web by LIDNUG on the 9th of June. Then we have Angela Dogan showing us his Julia and TFS 2010 in a testing environment. And of course, on the 23rd of May, we have Scott Guthrie coming back for his ninth session. There will also be his first session since moving from the Docker platform to the Azure Platform as a Service team. And of course, as usual, if you're not a member of LIDNUG, you should be. You can find us on LinkedIn, where we now number more than 43,000 members. Then calendars for our events. You can also get our events from Eventbrite, and we Twitter as usual. We also have a Facebook page. If anyone needs to get hold of us, email us at info@lidnug.org or email me directly at brian@lidnug.org. And thank you again from the LIDNUG team for turning up today, and apologies for the mishap for yesterday. Now, before I hand over to Theo, just make sure that our recordings are running. There we go. All right, Theo, thank you very much for joining us. Very much looking forward to this presentation. I'm going to hand over to you now.
Okay. Good morning, everyone, or good evening, or afternoon, wherever you are. So let me switch to, I will do LEGO for software engineers. So why LEGO? And before I go into this, let me quickly introduce myself. I moved roughly 4 years ago to the Silicon Valley. I work in Mountain View and sit in an office in my company, OmniSelling. We do healthcare safety systems and inventory management for hospitals. And if you're in the area or in Nashville and are interested in a job, I have some job postings at the end, but this is only one site. Previous to my work here, I worked in a factory automation company which did components, services, and products in that area, and we also did framework development. And besides this, I have a software engineering degree and also a degree in network communications, what I did previously in Germany. If you have any questions, just use the Q&A window, and I try to react to it as soon and quickly as possible. And if you have questions or want the code example or slides, they're on my blog, which is c#lighthouse.com. So I want to go briefly today into why LEGO for software engineers, and to be precise, this presentation goes strongly about dependency injection, but I don't want to do it just by itself. I want to show it just a principle in a set of tools used to write maintainable, extendable, and also reusable components and applications. And I will go into design patterns and principles and the best practices. I will go into dependency injection in detail. I have code examples for Unity. I do a little bit of comparison with the managed extensibility framework, and we'll a little bit talk about my experience. And I have a reference to what's out of my perspective right now. If you want to know about dependency injection, you must read book, which comes out soon, or you can already get it as an e-version. I will sum it up. I will go back and ask for specific questions, and at the end, I also added in a lot of references into the slides where I based my presentation on. So the question is, why Lego? All the examples of Lego you see within this presentation is actually models and construction sets I had myself as a kid, and I think it's a really great system to show how you build something which is reusable, extendable, something which has a really defined interface, and let you build something. And last but not least, I think people are really visual, and to have something to compare with something abstract like software makes it much easier to understand certain principles. If you have questions, let me know. Otherwise, I roll on and go to design patterns, principles, and best practices. These are the patterns and best practices I want to go into. So I will go into keep it simple, stupid, separation of concerns, and all the ones you see on the list. And this is just to give you a really brief, quick overview about what to expect. But before I go into this, let me ask you one first question up front. Who of you knows Lego, played with it, has it for its kids? Just to get a basic feeling on if you know why I reference it. And to be a little bit more specific, my examples are all Lego Technics, as that was the more preferred stuff for me. It's for the little bit older ones where you can really build technical stuff. Great. Let's move on then. When I studied, I had a really good professor at my university. I went in Germany to the University of Applied Science, which has to focus on providing solutions and not and solution-oriented engineers in my area, where the focus is not to be in specifically in R&D and to design something, invent something entirely new. And one of the key principles, one of my professors kept telling us over and over again was keep it simple, stupid, or short, kids. What it means, we have really complex problems by today. We try to address with our products and components issues which have a big amount of complexity in itself. Because of this, the solution should be as simple and as stupid as possible to keep it easy to understand for you and the next person going into it. And in a way, this means you keep it maintainable. And this is specifically one of the reasons why I took Lego as an example on and a comparison on how to write maintainable and reusable software, because Lego, as you can see, these are the most basic blocks you typically get in the picture. Have a really defined interface. For the simple blocks, they have the pin sticking out and the bottom, which allows you to stack them in certain ways. And in itself, this is a really simple thing. It's a few little pieces, but with the simplicity of each and every part having in itself, it allows you to build quite complex stuff. And this is what I think is the power of simplicity, that if you take components, elements, parts, however you want to call it, which have a really defined, simple interface, which are focused on doing one specific thing, you can build some really amazing things out of it. Just to be fair against the artist, I got the permission to use all the screenshots shown by Nathan Sawaya, and he is an artist, and he does amazing things like the Volvo, which is really out of Lego except the wheels, to my knowledge, and some of the other pictures in this presentation. So you can really build with something simple, something really complex, and still maintain a lot of structure in what you do. But having simple parts, however, doesn't mean you cannot build something entirely complex, entirely not understandable. You can still do it the wrong way. So how do you avoid doing it the wrong way, and how do you get to the point doing it the right way? In software engineering, two of the first principles which come to my mind if I want to write really reusable, and I'm coming out of the reusable business area, but it's not about only that you need to be able to reuse parts. It's often much more about that you be able to maintain and extend existing software. And basically, after you release the first product, the next version you will release is already, and you already extend that application, right? So you want to make it easily extendable. You want to make it maintainable. So the two principles which really go closely to each other for me, separation of concerns and single responsibility principle, help you achieving this. In short, what they both bring together, and they are not the same, and I have an overview in a second, but they're really close to each other, is saying one thing should do only one thing at a time. So if you have a class, one class should only do one specific task, have one responsibility at a time, but should do this very well, compared to, on the other hand, that even on a method level, one method should only do one thing. You should not do many things at the same time in your code, or in one method. What does it mean? If you think about your product, which is like this Lego car, right? You have a really complex product, and you want to take it apart and want to see it as components. You want to basically separate it in areas which are less complex and logically belong together. Like this part of, which comes actually out of this truck shown before. This is the steering mechanism. This is what in software would be either your component or service if you are in a component-oriented or service-oriented environment. So you take your whole product and break it down into more or less complex, more specific pieces, which you then call component and services, which in the end are composed out of simple parts. And simple parts in software, I would say, are something like struct, classes, enums, things which are really basic and have a really specific need. Any questions so far? Please feel free to type them in the Q&A, and I will respond back to it. So to always provide the feedback on and the definition. So separation of concerns, it's not new. I mean, it's 1974, probably. This is what the Wikipedia says and the information I could find. And it basically says that you should try in a computer program to have your features overlap as little as possible. Basically, focus on that one part of your software, one class, one component only does one thing. The single responsibility principle by Robert C. Martin is really similar, and I took actually something out of my code example, and I come to a little bit more code very briefly in a second. So I show the basic interface to what every one of us probably uses, something like a logger, which is in my code example. And as you can see, there's not really much to it. If you look on the functionality, there's a log method and the constructor, and that's it, because that's all you need. And that's what I would see as a part, and this is why I had this really specific Lego parts next to it. It's just one little piece in the puzzle of a software architecture which allows you to do a really specific task. Component-oriented programming. And we all, I think, are well used to object-oriented programming, and as someone very well known here, Jungeblut, says in his Architect's Masterclass, is software is evolving, and we evolved from structured programming into object-oriented programming. And the next step was actually to move into component-oriented programming, which means that you sort your objects into a little bit higher class component, into something really specific to a task which you then can take from one area to the next one. And something I will not go into detail in this presentation, as it would be one of many presentations in itself, but the next logical step, if you want to move in this direction, would be going from components actually to source-oriented programming, but I will not, the intent is not to go there with this presentation. Why components? To stick with the Lego example, showing two things doing something really similar. You basically see a Transformer, and as the next Transformer movie is coming out really soon again, I thought it's a good example. You can build out of something like Lego pieces, something which can transform in a similar way than this really specific Transformer figure. And of course, for Lego, and sometimes also for software, if you have more generic parts you reuse, they are sometimes not as specific and 100% down to the overall experience. No, sorry, this was the wrong word. To the overall appearance, than something really specific. However, the really big advantage is in software you don't see it because your UI will hide this in a much better way. But with a component-based architecture, like with this Lego example, you can build all kinds of very different things based on the same components, and that's where you can really gain a lot of benefit on the reusable part. So you can, with the same software building blocks, you can build different applications and reuse way beyond the simple level. in order to achieve this, I think one of the most important techniques is you need to separate your actual software from how you can use this. And this is something you do with interfaces or contracts. And I specifically not only say interfaces because we all think, like shown in the example below, with the source code out of my example, in .NET interfaces directly, but it can also be a contract, like if you use code contracts to even more specific, explain what your contract, your interface for a component does. So an interface allows you to basically be able to take one piece, one implementation for a specific interface, like the logger, and replace it with a different one without the software referencing it, having the need to change, because the interface is abstracting the implementation from the higher built on components. And I got this question. Yes, it goes a lot into design pragmatic programmers. I also do a lot of talks about clean code, which goes in the same direction. Another reference I always like to do for books, which are almost a must-read for developers, is the Clean Code book by Robert C. Martin. Maybe as we are here, let me allow you really shortly to show the code example to give you an idea, and I just switched to the last one of the principles. One of the things you should not do for many reasons is you should not repeat yourself. Drive, also one of them. What does it mean? I mean, sure, we don't want to repeat ourselves, but it's so easy in code. And here's an example which is not precisely like this in my code example, but it's a really simple way of showing the differences. So on the left-hand side, in the first block, I have I repeat myself by copy and paste reuse of code. And reusing code is really good. Copy and paste reuse is really bad, because the disadvantage is if you do this all over your application and you find out you need to change this one behavior, you change it in many places. Something I guess everyone's aware of. This is why I don't really want to spend much time on it. But if you look on how I refactored it for the try method, I basically just wrote an extension method doing my cloning in a secured way. I access it from my methods, and I have the string extension below. So if I now need to change the behavior, and actually this piece of code, as simple as it is, I have it many times in my products. It allows me to then change it in only one place, and this is what's really intended with don't repeat yourself. Dependency inversion principle, and this is not precisely what is IOC and inversion of control, but it is really, it has similarities, and I would just like to give it as a quick overview to something to look in. It only says that high-level modules should not depend on low-level modules. It's about how you build up dependencies, and dependencies complexity. I don't want to go into detail. I just want to say these are design principles. Take a look, and you will find some really good things. And I applied this in my code example in different areas to make your code cleaner, make your code smaller, make your code more maintainable and extendable. And this is where we go with dependency injections. And all these principles build the base dependency injection will build on. And Rossi Martin actually put many of these principles together in what he called SOLID, which are the single responsibility principle, the open-close, which means software should be open for extension and closed for changes. The linker's substitution principle, which means if you have a component which provides an interface and you have a different one, you should be able, as long as they both implement the same interface, that you can replace them without impacting the application. And that's actually what dependency injection is about. The last one we had, interface segregation principle. I don't want to go into detail. I just wanted to say there's many things to this out there. So let me show you the code example, as I had a lot of slides so far. So I have a solution here, and the solution has 8 versions of the same program, and each version of this program does precisely the same thing. I will start it once, and I hope I shared it in a way that I quickly need to adjust my share because I think it's not shared right now. Just give me a second. I apologize for this. So the code example I wrote is a contact manager. It precisely manages one contact, and you can try to save it. You can, of course, you can only save if there is something to save. You can load something, and you can delete something. And I implemented this in a really traditional, even outdated Windows Forms way, where a lot of things are concluded all in one class, doing some separation, but not in a good way. I then implemented it in just need to switch back to my Visual Studio to look at it. When I implemented it, this is something where I tried to write it how it was written it many years ago. All the logic is in the form, which is bad to start with. I have my buttons with events. I have methods, so I already took the logic out of buttons like event handler, but then I have methods like save contact, which do write something. I log the behavior, but I created a text writer in here. Then I created when I import from the UI the information into a contact object, then I check if I can save, if they can save, and then I basically if it's possible, save it, write this to the text writer, update my little status window, and basically exit. And as you can see, this code does a lot of things, right? It's not anywhere close to deal with one concern. The concerns in here is basically I do logging, I do getting information from the yarn into a real object. I check if I can save, and then I do logging again, and I update the status of my status bar on the button, and then I clean up. So I then took, and we will go into this example a little bit more. I wrote this application again, but I tried to separate it out by applying the previously principles. So I have three assemblies, one on the contract at the end, which has everything which is a public contract and needed for a public contract. It's having the interfaces, it's having enums, and an operation result object, which I use to transform more than just success or fail information, but also saying an operation was successful or not, and provided an error or warning information. I will not go into detail for this. But I separated the application out, and if you now look into my form again, I still have methods, private methods, which do the save, the load, or the delete. However, they are much smaller than before, because they really only do one specific.
Theo, excuse me, Theo.
Absolutely.
Just gotten a few requests. Can you speak a bit closer to the microphone? Thanks.
Oh yeah, I will just. I'm relatively close, but I will talk a little bit louder. Thank you. Please let me know. So I already applied like dry, like separation of concerns, like component orientation in this example, and this is then really building the base for dependency injection. This is what I want to go into now in more detail. So let me switch to the presentation again. Okay. Inversion of control. What does inversion of control mean? And inversion control is always and often just referenced as IOC. IOC means that what we do by today, and this is where IOC comes originally from. It's about object creation, and IOC was the term was created and the principle introduced by Martin Fuller in 1994, so it's already quite a time. So, but what it means is what I traditionally did. If I need a logger to say, okay, object name equals new object, then we should do this. We should avoid it. So why should we avoid it? Because we have objects which depend on objects, and which often depend on objects again, right? Building blocks. One builds on top of each other, and if you want to be able to replace one against another, or if you want to, even if you don't want to replace them, but you, for example, want to test them, how can you then take the database is often an example, but there are many different other things too. If you have a unit test and you don't want to always have a database doing the save in the background, and you just want for unit test to replace the database code, how can you do this if you have something like your database access object hard-coded like shown with the logger within your class, it's almost impossible. It's not impossible, but it's getting really hard, and it makes testing as one of the beneficiaries of dependency injections really complicated. However, dependency injection is not about testing. It's part which benefits from it, but dependency injection is not purely about testing. So I use IOC since 7 years myself, and I read a lot of things up on the internet. I read the original articles, of course, by Martin Fuller. I read many other good articles, but I need to say, and I was really fortunate because 1.5 weeks ago I met Mark Seaman, and he's right now basically in the final sprint of releasing a book on dependency injection in .NET. And he was in the Bay Area, he's from Denmark, and doing a presentation on dependency injection. And the presentation was really, really good. I really learned something myself, and I also started reading his book. And I need to say, if you really look for something, one combined source which walks you from begin to end through dependency injection, I think there's nothing better out there like his book, and this is why I really like to recommend it. Am I loud enough now? Please let me know, otherwise I will come even closer and speak even louder. So for dependency, for inversion of control, there are 3 principles Martin Fuller phrased. Constructor injection, setter or property injection, and interface or method injection. I really like to go specifically into constructor injection and setter property injection. I have the interface injection as a reference in this presentation, but I think the first 2, especially the constructor injection, they give you the most, and this is one of the things where I had to a little bit relearn things I did in the past on how to do it and how you can do it better. So what does constructor injection mean? Basically, out of my code example, I took this constructor. And if you look at the constructor, that's probably something you already have written many times by today without thinking about it. But you do inversion of control here. You inject an object to this class through the constructor. So you have my contact manager wants to have a logger and wants to have a contact persistence object. The contact persistence object is nothing else than to say, here's an object which allows you to save your contact, and it's taking care of this. So you can replace it. And the logger does nothing more than allowing you to log operations. And all the constructor does by itself is saying, okay, for my local field, the instance used for logging in this example, I take what I get with the constructor as a parameter and assign it to my field and use it from now on for the lifetime of this object. So why is this beneficial, and why does it make such a big difference? The difference comes with you don't get a specific logger. You get an instance of a logger which implements the iLogger interface, or the same for the iContact persistent interface. So your class doesn't care about if this is my dummy logger, which I use in the example, or if this is a database or a console line logger used for the task of logging, all it knows is it's an object which implements the iLogger interface, which allows me to write the previously shown message to execute the previously shown method log and takes the method. But you do not need to care within your class of the contact manager anymore about creating this instance. You don't need to know the specific object behind it. And this is where a second area dependency injection has moved into, and I think really Mark Seaman does a great job explaining it. Dependency injection also allows you to do a more specific way of lifetime management. This is not shown here, but this is another advantage you get. But this is really what constructor injection is about. Through the constructor, you get an instance which implements an interface if it's decoupled. Decoupling is what simplifies the architecture, and what inversion of control or dependency injection is about. You decouple the logger and can use it from here on, but you don't need to care about how it was created. It is just there. For the property or setter injection, it is a little bit different. So I took this out of my Unity example, and you basically you have a property, and instead of injecting your dependency through the constructor, you do this by a property which then can get set to any object which implements the eye contact assistance interface. So the mechanism, the mechanics are basically the same to constructor injection. However, the big advantage for the constructor injection over the setter or property injection is you see that you need this dependency right away in your constructor, in your public interface for the class. However, for the setter, you do not see if you need to set this or not, and this is where I needed to relearn, because I thought this is a good way to not have too many parameters to, getting into my constructor and doing it just by fields, where you also create complexity, because you can easily forget to set them, and then you have a problem. This is why suggestion and the recommendation based on the dependency injection in the .NET book is to use mainly constructor injection and go for the property injection if you have optional parameters and objects which may or may not be used. As I said before, for the interface injection, really this is out of example in code project and the definition. I think I will leave this because it's just a different way of doing things, and it's not that important for the ongoing presentation. But the references are included, and you're more than welcome to look it up. The last way described in the original article by Martin Fuller is the service locator, and that's something I used for 3 years, and I used it really successfully. What it is you basically have an object like your Unity container, or get service method, for example. What I did had in my architecture in my previous company, which was implemented, which allows you to say, give me an object get service, or like here unity container dot resolve. So you basically say resolve and ask the container to give you the reference, and it works very well. But there's a but with this, and it goes similar to the setup injection. And I had quite a little fun talking with this with the author Maximin, but he says this is actually an anti-pattern out of his perspective, and I'd like to explain it to you. As I needed to think about it for myself for a while to understand if I agree or disagree. The complexity introduced with this is that you can, within your code, within any of your classes or components, at any point of time, ask the container or whatever object you put the resolve or get service method on to get a dependency you need. That this is not obvious if you look on the public contract of your object or of your class. So if you have a class and it's implementing an interface and it's having a constructor which basically defines the contract for the class, you do not see that you may in a method like here in the initialize main form ask the container to get a specific dependency. It works great, but you run the risk that you miss this needed dependency, and your container is not aware of this because you didn't configure it within your container where you bootstrap the all the objects used for injecting your dependencies. And this is why Mark called it anti-pattern. And I can agree, I can see that this is much better than using new, but preferable to make your life easier. It would be good not to go this way, but really stick with something like constructor injection. As I included the service locator and I wanted to provide the differences and the advantages based on what Martin Fuller said is, the service locator, you can specifically say at a specific point of time when you want to get your dependency, and that's the big advantage. And it may or may not is a good idea to do this if you're in a closed on the closed platform where you own everything and you want to do it this way. However, as I explained before, going with the constructor or property injection is probably the better choice. Every time you think about dependency injection, you probably think about dependency injection containers are also often called IOC containers. And there are many, many IOC containers out there. I use as example Unity, but there is Cluster Windsor or StructureMap, Spring.net, Autofuck, Nginx, Pico container, and more. And you can easily write your own. So often it is beneficial to use an existing container because it already does a lot of things for you which you may otherwise implement yourself, but you do not need, you really do not need an inversion of control container to do dependency injection. And this is what I really like to show you now back in my code example. So in my changed example of which I called the clean version. I have the typical program class you have in a WinForms application, and I have a main in there, so nothing really different than before. The one different thing I did is I introduced execute pseudo bootstrapper and initialize main form class before I then do the application.run and provide the form. And this is really the difference to if I want to jump back to the program for the really traditional way, where you just go and say application.run and basically create your new form used for the WinForms application at that point of time. So why did I do this? Let's take a look into the code example. Within my bootstrapper, and I specifically took this method name, the bootstrapper part, to say it's something similar to what you do if you use an IOC container. What I do, I create my logger object, and I even inject with constructor injection the way how my logger then writes to whatever it is. In this example, it's a text file I'm writing to. And so I create my logger by using constructor injection itself, and then use the logger and put it into my contact manager and create a new dummy example contact persistence object, which handles the persistence of contacts for the contact manager. So, having this said, if you look into the contact manager itself, it knows about the iLogger object, it knows about the iContact persistent object, but it doesn't know on how to create it, it doesn't know where it comes from. It is decoupled, it already has dependency injection to the contact manager for these objects. I do a check if they're null and I throw an exception because I want to ensure that they really get the needed dependencies, because otherwise this class would not work. But other than that, I do not know about how this object was created. And this is really what is the simplest form of dependency injection. And now you could ask the question on why do I need an IOC container? But I think if you look into my really simple bootstrapper method in my program class, you see that there is another complexity in this. And this is how, if you have a really big, realistic application, you have many objects referencing many other objects. And of course you don't want to write this tedious code of saying, create this object, put this into this object, put this into this object, put this into this object. This would be another another complexity, and we try to avoid complexity. And this is where an IOC container comes really handy, because it basically does the mechanics about how to construct the objects, how to create the objects, and also how to do the lifetime management really for you. And this is what I like to show now with my Unity example. But let me quickly check if there are any questions, any new ones. Okay. Please let me know if you have questions, or Brian, stop me if I don't see it in the window, because it's minimized the PA while I'm in the code example. For my Unity example, I will use like for the MEF, the managed extensibility framework example, I will use out of my clean version the Lego DNF, the Jungeblut Lego demo.contract DNF, because my contracts never change between the clean version, between the Unity demo and the MEF demo. So these say always same. So what's the difference using Unity? If I look into my contact manager again, now you see something new. You still see my contact manager, and I split it up not because it really logically makes sense, but to show all the different ways of dependency injection, I used attributes. And just to be precise, you don't need to use attributes, and attributes also increase coupling, because now you need to note this attribute within in your class. But going this way, I can simply tell Unity that this is a constructor to use for injecting dependencies, and Unity then by itself will, when it's asked to create the contact manager object, look for an object of type iLogger and inject it in here. At the same time, I have the property injection shown here, where I put the attribute dependency, which comes with Unity, on this property to say, Unity, please inject this dependency for me. Other than that, my code itself basically stays the same, and this is why I'm not really into showing it into detail. But I really injected in two different ways the dependencies needed for this class. So now, of course, the question is, where does this dependency come from, and how is this done? So for this, we look into the program class again, and let me open it. And you see execute scrapper again. Actually, should have been execute Unity group scrapper and an initialize main form. So what happens in this two classes, in these two methods? In the bootstrapper, I create the Unity container, and you could use XML files for configuration, and I did this in the past in my previous company, and there are benefits into it, but you always trade one way of doing things with certain pains involved against new pains, and XML configurations have the pain that you can really easily make mistakes you do not see at compilation time, but only in execution times, where this helps by configuring how I did this here in my example in code, helps to some degree to see errors in wiring up my container and my objects at compilation time. Not all of them. Some of the wiring up will happen only because of the dependency injection at runtime. So if I, for example, would miss to register my logger, I then would at execution time get an exception because the logger object wouldn't be there to be injected by the Unity container when it creates a contact manager, for example. Okay. So for Unity, and there are always different ways, because of lifetime, how you can register objects and register types. So, for example, in the mark code, I register a type, and I say, if you get a request from iLogging sync implementing object, create a text file logging sync object and handle it back as it implements the iLogging sync interface. And this will be created every time somewhere in the code that there is the request of injecting this dependency. In comparison, on the next line for the logger, I register a type and I say, and I do this as a singleton, saying, okay, if anyone wants an iLogger object, create a logger object and have it in order to make it a singleton, a new container contact lifetime manager as part parameter for the register type method. So this basically shows you how to do singleton and non-singleton objects. And then you do the registration of the other objects in a similar way. And and this is specific to Unity, when I do my initial main form, I basically take the container and ask for resolving the single contact manager form. The form has nothing special itself that it would need to be injected, but by saying resolve, I basically ask Unity to create this object, a new instance of this object, and inject each and every dependency it needs, which then would be like the contact manager, or and the contact manager, which is a contact persistence object, and they both need a logger, where the logger needs a iLogging sync, and Unity takes care of all of this. So I don't need to write for each and every object how to put them into each other and write this manual, and Unity does it all for yourself. As the last example of something really similar, but not being considered inversion of control container, I'd like to mention the Managed Extensibility framework from Microsoft, which was introduced officially with .NET 4.0. The Visual Studio 2010 is using it as a new way of how to write extendable applications. And for many things, it looks really similar to what I have shown with Unity. And let me open the program again. So you have a main, and the difference here is because of how they work here. First have the initial main form and then the execute bootstrapper. And in this example, the main form is just created, and then I create a catalog, which is a collection of paths of things to be injected or created, and I use a catalog to create a container, and for the container I then say compose paths. And by saying container.compose paths and putting in the form, I basically tell MEF to create all my objects. And this looks really similar to what Unity does for dependency injection, or something Castle Winslow would do. But there is a difference. And the main difference is MEF was designed and written in the way it is by today for extending application. Think about Visual Studio, think about Photoshop, where you have third-party plugins to be easily added to an existing application and to be integrated without having the ability, the need, or even the ability to recompile or even change the configuration of the existing application. So MEF uses discovery to achieve this, and you can see this. I make an assembly catalog and say, okay, take my executing assembly, get it via inflection to create this catalog, and I get a directory catalog based on where I say, here are my assemblies. And MEF goes and does do a discovery on this specified assemblies or the directory with assemblies, and looks through each and every one for the attributes, which are in a really similar way if you compare it to Unity. So the attribute is called a little bit different. It's called importing constructor, and it's always for MEF. It's always needed for Unity. It's just one way and an optional way, but it also injects the needed dependency. So why is this not? Is MEF not considered a real IOC container? The first thing is you always depend on the attributes to define what the import and the export is. Import is something you need, it's a dependency you need to be able to function, and you need to import. And export is basically a piece of software which provides the dependencies then discovered by MEF. And really one big difference is object creation and lifetime management. With any of the IOC containers, you have one central place, basically in your configuration, in your bootstrapper or in your configuration file, whatever you prefer, where you define the lifetime of an object and where you handle this. So you concentrate all the object creation and lifetime management in one piece of code, which is really where you where you compose, where you wrap up all the components used for your application to build it up. Where in difference, MEF requires you to define if you have shared or non-shared, so basically singleton or non-singleton imports or exports, and you need to define it on the export and on the import. And it's done in most cases automatically for you, so if you don't specify it for an export, it will be it can be either shared or non-shared, and you can define it by default on the import. But you basically you clutter this throughout your code base. You need to have this in your classes, and this is where it creates coupling again, because you need to know then in your code base, if you consume something, if you import a dependency, the way how you want to import it. And you may need, if it's specific for the export, that it can only be shared or only can be non-shared, you need to specify it there, and if it doesn't match, MEF will throw an exception when it builds up the application. But this is really where there is the difference. MEF, from what I heard, is more and more evolving towards the IOC container. Actually, for the longest time, the team said you can use it in parallel to IOC. There are two different things, and shortly after the release, they said, yeah, you know, or you can do this, but actually, we're coming pretty close to being an IOC container, which they are not by today. But there's a good possibility that with a future release, they move closer to it. And having this said, this is where I like to stop with the code example and really go into the final slides and into any questions from you. So, coming back to the slide where I left to the source code, there are many dependency injection containers, and they typically do constructor injection, property injection. There are service locator functionality. As you saw, you can say container that resolve and gives you for Unity, for example, the dependency. But there are also related technologies, and the one which is really closely related is MEF, the Managed Extensibility Framework. And the last one I like to mention, but not really go into details, is to say, if you go from components to the next steps towards service orientation, you easily end up thinking about Windows Communication Foundation, because you can build a really similar application, and I did this with some improvising and loopholing in my last code example, where I used WCF and the in-prod factory from iDesign for basic creating WCF services in process, and having WCF work as a kind of dependency injection mechanism. But the reason I did this is Windows Communication Foundation provides many things you want to have in the context of dependency injection, of decoupling of your system. It allows you in great detail to do lifetime management, do handling about how to avoid deadlocks, for example, by saying a method should been executed by this period of time, otherwise throw an exception. It allows you to do transaction handling, which is basically built in. And one thing most IOC container also do by allowing to inject aspect-oriented programming by basically interacting with the object, which is the subject in itself. Yeah, also have a great flexibility there with Windows Communication Foundation. Is this something you would do by today? I think we will move closer to this in the future, but by today, Windows Communication is about communication, but there could be benefits of doing it this way. And if you're curious about this, Juvalui has a presentation to this called Every Class a Service, which is something worth listening and seeing. As I said, the most complete reference, example, and explanation about how you should do dependency injection, how it works, which mechanisms, which patterns, besides the ones I displayed, and explain today are helping to use as one of the many tools in your toolbox for doing decoupling of components and writing reusable and maintainable applications. Look into the dependency injection in .NET book. I think it's really a book worth reading and spending the money on it. To sum it up, in order to do write better applications, and it's not just about the reusability, it's really about the maintainability. You achieve this through simplification and specification, and this is what was KISS, SOC, and SRP about, and through decoupling, where interfaces, component-oriented programming, dependency injection principle, and IOC are also saw work into. And last but not least, coming out of the clean code area myself, you should try to avoid code blow. And I spoke about dry. I didn't go into you aren't gonna need it, but it will be another one. And all of them help you to write better testable and maintainable application. And as I said before, if you live anywhere or close or be interested in jobs in Mountain View, so it's in the Silicon Valley or in our Nashville office, we have, for the company I work for as a healthcare company, many positions open on different levels, and you're more than welcome to contact me if you have questions or to apply directly. Having this said, I'm now open to any questions and feedback, so feel free to post on my blog comments or to send me an email if you have questions, and that would be it for today.
Excellent. Thank you very much, Theo. That was a very technical and in-depth presentation, and I'm pretty sure quite a few people enjoyed it. Just gonna bring back my slides up for a second.
Sure.
Give me a second. There we go. Alright guys, thank you for sitting in on this. As Theo said, if you have any comments or questions, feel free to contact him. Just to reiterate as well, June we have LIDNUG doing open data for open web on the 9th of June, and they're doing taking us through testing with the Studio and TFS 2010. Of course, Gotthard's 9th session on the 23rd of May. Any questions or anything else, feel free to fire them through, and we'll do our level best to answer it.
I have one question. Is the date for Scott the 23rd of June? Because it says May.
Let me see. You're absolutely correct. It is the 23rd. Let me know you got me all convinced here. Let me quickly have a look at that. It should be the 23rd of May or June. Maybe it's not. It's the 23rd of June. There you go. Obviously, a bit of a typo. Thanks for that, Theo, for that correction.